Okay, we're going to talk about vectors. Vectors are essentially rays, and they float anywhere in space. So we have a vector right here, this blue line, and it's called vector u, labeled like that. The unique thing about vectors is that they don't have to be anchored right here at the origin. They could float anywhere in space. So as long as I drew a line that was the same direction and exactly the same length, although mine isn't, it's a little too long, that would be a similar vector. U could be down here, it could be over here, it could really be anywhere as long as it's the same length and direction. Which brings me to how we talk about vectors. So vectors are magnitude, which is essentially the length of the vector, and direction, which is essentially the angle of the vector. We also talk about components of the vector. The components of this vector are A and B, and what that means is A is the horizontal length and B is the vertical length. And we would list component form by listing A, B. So for purposes of talking about this in terms of numbers and not just letters, let's draw this vector down here. We'll say it's still vector u. And just to help us get oriented, we're going to sort of sketch in an origin here. Now, let's say that A, this horizontal length, is 4, and B, the vertical length, is 3. Notice that when drawing horizontal and vertical lines from a vector, we have a right angle. And essentially, all vector work simplifies down to just working with right triangles. So if we want to find the magnitude, we really just want to find the length of the vector, which is x. And if you look at it as a right triangle, we're really just looking for the length of the hypotenuse, and we're going to use the Pythagorean theorem. Now, magnitude is labeled with these double bars, so if we want to find the magnitude of u, it would be written like this. You could have the arrow here, but the double bars mean find the magnitude. So to find the magnitude of u, we're going to consider the Pythagorean theorem, which is 4 squared plus 3 squared equals x squared, and to find x, we're going to take the square root of both sides. 4 squared is 16, 3 squared is 3. Add those together, we get 25. Square root of 25 equals x. That means that x equals 5, or the magnitude equals 5. The other measurement that we look for in vectors is the direction. And when we're talking about direction, we're talking about the angle. Specifically, the angle starting from the x-axis and working its way around, just typically how we think about going around the unit circle. And so this one, we're just measuring a nice little acute angle here, and this angle that's down here is the exact angle we're looking for. So to find that angle, we can use tangent. So recalling our triangle trig, SOHCAHTOA, tangent is equal to the opposite side over the hypotenuse. Sorry, that is not correct. Tangent is equal to opposite side over the adjacent side. Right number, wrong word. So tangent, opposite, adjacent. And then if we're finding the tangent of a specific angle, we need to use inverse. So we're going to say the inverse tangent of 3/4 is equal to the angle. And when we put that into our calculator, I believe it was like 36 degrees. So that angle is equal to inverse tangent of 3/4 is, 36.87 degrees. So that would be one way that we can talk about the direction. We could also talk about that direction in terms of a compass. So if we think about it being north, south, east, and west over here, we could say that the direction is 36.87 degrees north of east. So we're starting from east and we're heading in a northward direction, 36.87 degrees. Just two ways to talk about direction of a vector. Okay, so let's do a little practice with this. We have a vector v drawn here. And because it's drawn on a grid, we can see that the components are -4, 2. So we went back 4 and up 2. And if we're orienting ourselves on an axis, we would draw in the y-axis like this and the x-axis like this. Okay, so if we want to find the magnitude of that vector, magnitude being the two lines, then we want to find the length. So if we have a length of 4 here and 2 here, and the signs don't really matter because we're going to square them, we would take 4 squared plus 2 squared is equal to our length that we're looking for, and then squared, and then we're going to square root both sides. So x would be equal to the square root of 20. Square root of 20 can be simplified. You could also write it as 2 times the square root of 5. Either answer would be fine. So that is the length or the magnitude of the vector. We can also find the direction of the vector. So if we're talking about direction, we're talking about the angle that starts here at the x-axis and goes all the way over to our vector. So this we're looking at as an obtuse angle, one that's greater than 90. And the best way to find that is to find this angle in here and then use that. So to find that angle, we use tangent again. So tangent of that angle is equal to opposite over adjacent. And the inverse tangent of that angle, sorry, I'm pulling up my calculator here. The inverse tangent of 2/4 is the same as 1/2 is equal to 26.57 degrees. Now we could talk about this angle in terms of a compass. So if we say this direction is west and we want to go that many degrees north of west, we could say 26.57 degrees north of what? Whoa. North of west. Too close to the corner here. So we're just going to leave it as W, north of west. But the more standard way of talking about this is just talking about it within the unit circle. And so we know a whole, if we were to go all the way back to the x-axis, it would be 180 degrees. So we just take 180 minus that angle. And then the resulting answer would be the direction, 153.43 degrees. So 2 possible answers when we talk about direction, and they're both talking about a vector that's heading from its anchor point this way. Okay, one more thing that we're going to talk about in this video, and that's vector addition. So we have 2 vectors here being added together. Vector A, which is -3, 7. So if I draw that out, I would go back 3 and up 7. Did I count that right? 1, 2, 3, 7. Okay. So here's vector A. And then we're adding vector B to it. And vector B is 4, 1 for components. So when we add vectors together, we start from the end of the last one. So I'm going to start here, and I'm going to count over 4 and up 1. So vector B ends right here. And what we're really looking for is vector C, which starts at the beginning of the first vector and ends at the end of the second one. So we have this vector here, which is vector C. And if we want to list the component form of that, from the origin we're going to go +1, and we're going to go up 8. And so our new vector would be 1, 8. Now you don't actually have to draw this out in order to add them. If we look at this number here, we got it by taking -3 plus 4, that gives us positive 1. And if you look at this number here, 8, we got it by adding 7 plus 1 to get 8. So you just take the x values, add them together, take the y values, add them together, and that gives you your new component form. And then of course we could find the magnitude and the direction of that vector if we wanted to. If we wanted to find the magnitude, we'd write it like this, and we could potentially find the angle measure or the direction. So that's an introduction to vectors. In the second video, I'm going to talk about if you have the if you have the magnitude and direction of a vector, how you can work backwards to get component form, and then how vectors are used in word problems.